তো সলিউশন চ্যাপ্টারটার মতোই একটা চ্যাপ্টার ছিল তোমার ক্লাস 11-এ, সাম বেসিক কনসেপ্টস অফ কেমিস্ট্রি, প্রথম চ্যাপ্টারটা। ওইটা রিলেটেড হচ্ছে এই চ্যাপ্টারটা আর কি। ওইটার মধ্যে কয়েকটা টার্ম আমরা পড়ছিলাম, যেমন নর্মালিটি, মোলারিটি, মোল ফ্র্যাকশন, এগুলি পড়া আছে, মোল কনসেপ্ট। তো ওইটা রিলেটেড একটা টপিক আমি শুরু করতেছি, মোলারিটি। এটা খুবই ইম্পর্টেন্ট টপিক। মোলারিটি এই দুইটা রিলেটেড কোশ্চেন প্রত্যেকবারই আয়ে পরীক্ষাতে। মোলারিটি জিনিসটা কি, হোয়াট ইজ মোলারিটি? ঠিক আছে, ধরো কোনো একটা সলিউশন বানানো হয়েছে, এটার ভলিউম 1000 ml সলিউশন। এটার মধ্যে যত নাম্বার অফ মোলস সলিউট থাকবো, দা নাম্বার অফ মোলস সলিউট প্রেজেন্ট। ধরো এটা আমি স্মল এন ধরে নিলাম। 1000 ml এ যদি স্মল এন নাম্বার অফ মোলস কি থাকে, সলিউট থাকে, then the molarity of this solution is n mole, n molarity. The unit of molarity is moles per liter, because 1000 ml means 1 liter. So 1 liter in 1 liter solution n number of moles are present, so moles per liter. So this is the, and we can denote molarity by capital M. Okay, and another thing, number of moles n equal to, the formula is mass by what? Molar mass. You can write it out, note it down. Okay, now another topic is molality. What is molality? If we take 1000 gram solvent, not solution, in this case solvent, the number of moles of solute present is known as molality, and we can denote this by small m. Previous one was capital M, this one is small m. In which school you belong? Your name? Sorry? Done? Another important topic is mole fraction. Suppose you have a solution in which the components are A, B and C. 3 components are mixed to form a solution in which number of moles of A is N1, number of moles of B is N2, and number of moles of C is N3. So total number of moles equal to N1 plus N2 plus N3. Clear? Now if we calculate mole fraction of, suppose A, we can denote it like this. It's not X, it's chi. Okay, chi A equal to N1 by N1 plus N2 plus N3. So the formula is number of moles of this component, of that component, by total number of moles. Clear? Same with chi B, N2 by N1 plus N2 plus N3. Same with chi C, N3 by N1 plus N2 plus N3. Okay. Now if we add chi A, chi B and chi C, what will we get? 1. Very good. So the sum of all the mole fractions of the components in a solution is what? 1. Clear? आपका जो स्कूल का जो नेक्स्ट एग्जाम है वो कब है? 24th of this month. Which chapters are there from chemistry? Okay. You have to buy the book very fast, very quickly. Sorry? Chemistry. Modern ABC. लिख लीजिए नाम. Modern ABC of SP Johar, the writer's name. Next is sorry. No. These are the mole fractions. Total number of moles नीचे डिनोमिनेटर में है और जिसका मोल फ्रैक्शन आप निकालोगे उसका नंबर ऑफ मोल्स ऊपर रहेगा. ठीक है. Next in is Henry's law. अगर कोई सॉल्यूशन पे हम कुछ गैस डिसॉल्व करते हैं तो उसका जो प्रेशर है वो मोल फ्रैक्शन के साथ प्रोपोर्शनल रहेगा. मतलब if we dissolve any gas in a solution, then there will be pressure. The pressure will increase. No. Suppose we are packing something in a bag. We will go out for a trip and we are started our packing. And after some time the bag will become full and then we will pressurize it, give pressure and then put another things, lot more things. So as the number of things or quantity of things is increasing, the amount of pressure is increasing or decreasing? Increasing. So Henry suggests a law which is known as Henry's law. He stated that if we dissolve any gas, in a solution, then the amount of pressure is directly proportional with the mole fraction of this gas. Clear? Why mole fraction? Because if the amount of gas increases, then the mass of gas increases. And if the mass of gas increases, then the number of moles also increases. Okay, and if number of moles increases, if numerator increases, then the whole fraction is increased. That means mole fraction is increased. So pressure is directly proportional to what? Clear? This is known as Henry's law. The mathematical form is like that: P proportional to X or chi, whatever you can say, and P equal to KH into X or chi, whatever you say. Okay? Here KH is known as Henry's constant.
Is there like value of?
It depends actually amount of pressure and amount of mole fraction. It depends. Okay, there is no specific value of this. Likewise, we get some constant has actual constant values, but some don't have. Okay. Next topic is vapor pressure. What? Vapor pressure. What is vapor pressure? Suppose we have taken a vessel in which some solution are there. Okay. And we start to give temperature, heat, and after some time it will start vaporize like that. नीचे से धीरे धीरे ऊपर जाएगा. It will start vaporize like that. And if we give something very thin here, thin metallic type something, then after some time it will push this. We find these in our home when mother make food, rice for us. We find that. দেখেছো কোনোদিন এরকম যখন গরম হয় ভাতের ঢাকনাটা যখন লাগানো থাকে তখন ঠক 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 করে কাঁপতে থাকে জিনিসটা. This is called vapor pressure. The amount of pressure which has been given by the vapors inside the vessel is known as vapor pressure. And one scientist, Raoult, proposed some laws with vapor pressure. Then you have boiling point, then melting point. He proposed some laws. Yes, two types. Yes, good. Volatile means if we add something which will boil with water or solvent. Suppose you have taken a solvent B and a solute A. This is the solution, A plus B. Okay. Now the solvent will vaporize for sure, but the solute you have taken, it either can it can vaporize or it cannot vaporize. Okay. The solutes which can vaporize are known as volatile, and the solutes which cannot vaporize are known as non-volatile. Okay. Now suppose in a classroom, suppose there are 10 students. Okay. Everyone pay 2,000 each. What will be the income of the teacher from this batch?
20,000.
20,000. You are good in maths. Why they are saying that you are not good?
This one was too easy.
Okay. One day you will become a good one. Be positive always. Okay. The income of the teacher from this batch is what? 20,000. Okay. Now, more 5 students join the class. The income will increase or not? Increase by how much?
10,000.
Very good. 10,000. So the income of the teacher is directly proportional to the number of students, but there are some students which belong to poor family. For them, we teachers give some you can say facilities. Suppose the students, the 5 students which have come later, to join later rather, don't pay any tuition fee. Then will it affect the income of the teacher? No. Number of students are increasing, but the income remain same. So these students are non-volatile. If they will not pay any tuition fee, then the number is increasing, but the income is not. And these type of solutes are known as non-volatile solutes, which will remain in the solution but will not vaporize. And if they will not vaporize, they will not give the push to the vessels. Okay. These are called non-volatile solutes, and the solutes which will vaporize with the solvent and will help to push to give the pressure are known as volatile solutes. Is it clear? Okay. Now Raoul proposed 2 laws, one for volatile, another for non-volatile. For volatile, he said that, or he stated that the total pressure, the total vapor pressure will be the sum of the pressure given by solvent and also the pressure given by the solute. Both will come. And in the case of non-volatile, he said that only the pressure of the solvent particle will come. Okay, this is the main 2 laws of Raoult. Clear? Then another thing, another 2 types of solution, ideal solution and non-ideal solution. The solutions which obeys Raoult's law are known as ideal solutions, and the solution which doesn't obey Raoult's law are known as non-ideal solution. Clear? Then you have azeotropic solution. What is azeotropic solution? Azeotropic solution is, suppose we have a solution in which A, B and C are present. Okay? In the ratio of A, B and C is, suppose 3:2:1. Now we start to boil it and we have closed the vessel. with a metallic plate. It will start vaporize. It will go there. It will push, and also if we take the plate out and make it cold, then make it freeze rather, then the vapors will become liquids. This process is known as condensation. And then if we check the ratio of A, B and C in that solution, in that mixture, which one? Condensation. After condensation we get. And if the ratio remains same, then these type of solutions are known as azeotropic solution. Clear? Another thing is colligative property. There are some properties which only depend on the quantity of the solute, not on the quality. Suppose again I will come to tuition batch. A teacher has 100 students. Everyone pays. In this case, how much? 2K. Now, in these 100 students, suppose 80 of them haven't cleared any entrance exam. The remaining 20, 15 cleared JEE means, 3 cleared TBJEE and 2 cleared NEET. Okay. Now, the quality of these 80 students, we can imagine, are not good enough. These good, more than good, J means more than good. They good, TBJEE. They are tremendous, NEET. Okay. Clear hai? Now, the number of students is 100. Payment is fixed. So the income of the teacher, is it depend on the qualities or the quantity? Quantity. So these type of properties which only depend on the quantity, not on the quality, are known as what? Colligative properties. Okay. For example, not tuition master. Example is what? Relative lowering of vapor pressure. Relative lowering of boiling point or freezing point. Suppose water freezes at what? 0 degree C. If we add salt or sugar to this water and try to freeze it, what do you think? Will it freeze at 0 degree C or the freezing point will change? Will change. Will it go down or up? Will it go negative or positive? Any idea? It will go down. It will become minus 5 degrees C. And if we add more sugar or more salt, it will become minus 10 degrees C. So the relative lowering of the freezing point is depend on directly proportional to the number of moles of solute we putting in, not on the quality. It may be sugar, it may be salt, anything you add, the freezing point will go down and down and down. So this type of properties are known as colligative properties, which only depend on the number or quantity, not on the quality. Okay. Another example of colligative property is elevation of boiling point. Suppose water boils at what? 100 degrees C. But if we add sugar, salt, these type of things, the boiling point will increase. It will become 110, 105 like that. So this also depend on the amount of sugar or salt you putting in, not on the quality, it depends on the quantity. So this is also a colligative property. Another thing is osmosis and osmotic pressure. What is osmosis and osmotic pressure? Which one is more concentrated? This one. If particles can enter from this one, what do you think? Suppose this is A, this is B. The solvent particle will go from this to this or this to this? This to this? No. This to this, so that the concentration, and this phenomenon is known as osmosis. Now this will go from this. Now if we give some pressure here, this path will feel some effect of this pressure. You are trying to go like that and someone is doing like that. You will not go that far. Same here. It is going like that, but someone is giving pressure here. And if we increase the pressure, at some point this osmosis will totally stop. And the amount of pressure which will make this osmosis stop is known as osmotic pressure. Clear? And if we give osmotic pressure and stop and then again put more pressure, what will happen? Yes, it will go like that, and this phenomenon is known as reverse osmosis. So the definition of reverse osmosis is like that. If we put, or if we apply is the best word here. If we apply pressure more than osmotic pressure, the phenomenon reverses, and which is known as reverse osmosis. Okay, write one application of reverse osmosis. If I ask you, what will be the answer? Application of reverse osmosis. The salt we get from ocean or sea water is an application of what? Reverse osmosis. Okay. And today's last topic, Ventor Flow. Which states that pi equal to CRT. What is pi? Here pi is osmotic pressure. Osmotic pressure, and this osmotic pressure is directly proportional to concentration. If concentration increases, the rate of flow will increase, and to stop this we have to put more pressure. So the osmotic pressure is directly proportional to what? Concentration. Again, osmotic pressure is directly proportional to temperature. If we apply heat, the kinetic energy of the particle will increase and the flow will increase. So we have to give more pressure. That's why pi is directly proportional to T. And by combining both, we can write pi proportional to C into T. And to make it equal, we have to, yes, and this constant is R. So pi equal to CRT. This is Ventor flow. Done? You have WhatsApp? Give me, I will give some questions. You have DNA block, haloalkene, haloarine, and this one. I will send the questions. You have to write all this. Okay. You write. Okay. I will send you tomorrow. How was the class? Understand all the things? Now you have to study all these topics from NCET book today. Okay. And if you feel any problem, then ask me in the next class. I don't think any problem will be there. But you have to study today, tonight actually. After some time, all the things will erase from our mind. Okay. Done for today.
Biology.